Okay, so let's start. Good morning, everybody. So, in the beginning, I want to first remind you of what we did so far and what is remaining in this chapter. Okay, so what we did so far, number one, when it comes to MAC addresses. So as you know, as I told you before, MAC addresses are flat. Okay, flat means it does not have hierarchy. Okay, and also MAC addresses are portable. Portable means your laptop has only one MAC address. Okay, so that means when you come to the university, when you join the network of the university, you are going to use this MAC address. When you go home and you use your laptop, you are going to use the same MAC. So anywhere you go, you are going to use the same MAC address. Okay. And as you know, I told you MAC addresses are used in layer number two. And actually MAC addresses are identifier for computers in the same network or sub-network. Okay, so this is actually identifier to hosts or computers in same sub-network. Okay, because later we're going to use the word network when you have multiple sub-network. Okay, so here inside the same network or sub-network, okay, MAC addresses is identifier inside the MAC addresses. Okay, now let's come to IP addresses. So IP addresses, you should understand it's globally unique. Okay, so in the whole world, every computer has only one MAC, one IP addresses. Okay. Also, as I told you before, they have hierarchy. Okay. And MAC addresses, IP addresses are related to the location. So when you come to university, when you join the university network, you are gonna have an IP address. But when you go home, you are gonna have a different IP address. So wherever you go, you are gonna change the IP addresses because IP addresses are related to the location. Okay, so it has hierarchy. Okay, so. And as I told you also before, this one is used in layer number 3. Okay. And as you know, layer number 3 is used to connect any host or any computer to any other computer. So in order to better understand what I mean by hierarchy, okay, and also what was the meaning of hierarchy, and also to understand the idea of network of networks, very important to understand. Okay? So what I did here in this chapter to understand the idea of hierarchy. So let me go back just to remind of what we did. I told you here in this chapter, any IP addresses, actually it has two parts as we see here. One part for the network ID and one part for the host ID. When I say host again, it means computer ID. Okay, so that means if you look at an organization or an institution, like for example, Qatar University, for example, or any other institution, there is one part common here. This part is common in the whole university. This part we call it network ID. Every computer inside the network, it has a different host ID. Okay, and as I told you last time, and as I also give you several examples last time, actually what happens is that when I give you, what happens is that an institution like Qatar University is gonna get a block, a group of addresses, set addresses. Okay, this university is using a number of addresses. Okay. All the addresses, this part is common in all addresses used by Qatar University. This part as an example for sure. This part is common. Okay. And now we have the idea of subnetwork. You should understand subnetwork. Okay. So subnetwork, as I told you last time, is so subnetwork is, for example, here, if this is one network, like for example, Qatar University network, okay? Inside this network, we have what we call subnetworks. So here we have a subnetwork, subnetwork, subnetwork. They are connected together using routers, okay? We have a number of subnetworks. For example, this building can be one network or maybe more, okay? Other building is gonna be another network and so on, okay? So now we have what we call network address. Network address. This network address is common, is common for the whole university. Okay. And the beauty of this idea is the rest of the internet is gonna see you using only this network address. Okay. So any message coming, any message that has this network address, I'm going to send it to this university without knowing the details. I don't need to know how many subnetworks you have inside Qatar University. I don't even need to know this subnetwork. Okay, so all what I'm going to do to send the messages to this Qatar University, all what I have to do, I'm going to see the network address. Okay, and then inside the network here, and that's what I explained last time, inside the network, you are going to use the subnetwork. So here outside Qatar University, we use the network addresses, but inside here, we use the subnetwork addresses. So what do you mean by subnetwork? It means every subnetwork here, all computers in this subnetwork, again, we agree, all computers in Qatar University has the same network address. We agree on that, okay? Inside every subnetwork, all computers in these subnetworks have the same subnetwork address. So now we have network address, we have subnetwork address. Is that okay? So the outside world doesn't need to know the subnetwork addresses. The subnetwork addresses are used internally in Qatar, inside the Qatar University. Okay, that is why here, before the break, I explained this idea here. Yeah, I explained. Now you have network ID, and now I'm gonna divide it into sub network ID and then host ID. Okay, the whole university has this part is common in the whole university. Okay, inside the university, every subnetwork, this part is common in the whole university in this subnetwork. Okay, that's what I mean by hierarchy. MAC address doesn't have that. So MAC address doesn't have this hierarchy, just a flat number. Flat means like random number. It doesn't have a structure like this one. Okay. So now, so if you have an IP address, and as I told you before, the IP address is actually 32 bits. If you have an IP address, so using the IP address, you should be able to find the network ID or network. By the way, don't be confused between network ID and network address. They're almost the same. Network ID means this part. That's the meaning of network. So when I say network ID, that means it is this part. Okay. When I say network address, any address should be 32 bits. Okay. So actually, I'm gonna put 0 here in the host part. Okay, so I'm going to keep this one, put 0 here. That's what we call a network address. Okay, same thing when I say the sub network address, I mean this part. I'm gonna take this part, network ID and sub network ID, and then I'm gonna put 0 here, and this gives you the sub network address. Okay, so now, if you have an IP address and you want to find the network ID, we use a mask. As I told you before, we use a mask. And I told you in exams, I'm not going to tell you, I'm not going to give you these masks because you can, you need to know them based on the class. So as I said before, so for the network address, take a seat. Take a seat, listen to me. Okay. So here, when I give you an address, you should be able to find the network address. Okay. I'm not going to give you the math. It's just very easy. As I said before, you need to know if from the address you can know class A or class B or class C. Once you know the class, you can find the mask easily. Okay. So here in class A, as I said before, the first byte here, the first byte is actually the network ID. For B, it is actually 2 bytes. For C, it's just 3 bytes, as I said before. Okay. But for the subnetwork, for the subnetwork, to find the subnetwork, so that's what I explained last time. For the subnetwork, I'm gonna give you the mask for this one. Okay. And as I also told you before, we have for the mask. So again, that's what I explained before the break. The idea of the mask. So a mask is used to calculate or to find the network address or sub-network address from the IP. And this will be a question in the final. It will be, okay, because this is important thing and it will be. So I'm going to give you, and you have many examples here. I'm going to give you IP address. I'm going to ask you, give me the network, give me the sub-network, and so on. Okay? And you have a lot of examples here I explained before. So it came the idea of using a mask. And the mask actually has 2 formats. So the mask can be something like that, okay? And in this case, you can use AND bit by bit or bitwise AND logic AND to calculate the network or subnetwork. Also, it can be using a slash, as I explained before. Anyway, so also I told you here about routing tables, okay? So I told you here in the way the routing tables are made is actually, as you see here, we have a mask, okay? And then I'm gonna apply the mask, and then I'm gonna compare. I'm gonna compare the network to this network address. If it is true, I'm gonna forward to through this interference. So for example, I give you, and also this may be very attractive for me as an instructor to bring you something like that in the final exam. I already explained, I think, 2 or 3 examples here, and you have one question in the homework related to this one. If I give you a network like this one or a connection like this one, and then I'm going to ask you to make a routing table, okay? So here in this routing table, as you see here, the idea of the routing table here, once the router receives an IP, the router is going to apply the first mask here. And then if the result is actually this network, so I have to forward it to M2 through M2. So here, the router here has M1, M0, M3, M2, and so on. Okay. And then if this one is false, so now I'm going to try this one. I'm gonna try this mask. Okay, if I get this address, so I have to forward it through M0. If it is not, so I'm gonna try next one. If it is not, I'm gonna try next one. If it is not any of these, so I have to send it to this router, as I told you before. So the rest of the internet. Okay, so just again, very simple. I need from the IP, I'm gonna calculate the network address. If I find the network address here, so I'm going to forward here. If I find this is the network address, so it's going to be this way. If this is the network address of the IP, it's going to be this way. If it is this one, it's going to be this way. If it is neither, if it is not any one of these ones, so in this case, I'm going to send it to this router, okay? So what is, to completely cover this topic, what is left? What I'm going to teach more in this topic, okay? I'm going to teach two more things I didn't teach, okay? Number one, here, I assume you already, the first thing here, I'm going to teach is about IP assignment. So it's a very small topic. How can you get an IP? I told you, when I come here, I'm going to get an IP. When I go home, I'm going to get a different IP, and so when you change your location, you change IP. So I need to know how you are going to get an IP. Okay, so that's what I'm going to teach. Also, the other topic I'm going to teach is routing. routing table. Here, I'm telling you, you have the routing table, but how this routing table are created, we need to use a protocol or algorithm. We call it routing protocol. Okay, so routing protocols are responsible for creating routing tables. Okay, so I didn't teach this one as well. Okay, so I think before, so these are the two topics I here in this chapter, but before, yeah, so here the first one here I'm going to teach address assignment. Second one here, routing protocols. Routing protocols are used to create routing tables. Okay. Once, as you know, if you have a router, once you have a table, when I receive an IP, I'm gonna see the table is gonna tell me for this IP, should I forward this way, that way, or this way, and so on. Okay, as I said before. So now before I do that, I think I didn't teach the I didn't teach these examples here. So let's start with this example first. So here I'm telling you in this question, we have a small organization. In this small organization, we have this address for this organization. I'm asking you, what is the range of addresses in the block? Okay. Again, so here this organization will give a block of addresses, a number of addresses to this organization. The block of addresses should be something like that. Okay, that means, you know, this part should be common for all of them, but be careful here. As I told you before, when you have 29 here means this is the first. So here in total we have 32 bits. 32 bits. Out of the 32 bits, we have 29 is common. So this is the network ID. So 29 is common. 29 is common for all of them. Okay. And then now, so out of the 32, how many left here? Okay. So we have 3 bits. Okay. So, and that's exactly what you see here. So what you see here is, yeah. So here we have from here to here is actually 29. And this is 205. 205 is here. 16 is here. 37 is here. The last byte, 24, actually is going to give you this part. So this part alone is 24. And then we have here only 3 bits. Okay, that means the range of addresses given to you when I tell you, I give you this address block. Again, this is not only one address. This is a number of addresses, block of addresses given to an organization. When I say that, that means you have first of all, how many addresses do you have? Very simple. Now you have only 3 bits, right? 3 bits. As you knew before, if you have 3 bits, you can actually 2 to the power of 3. This is the number of addresses you can have, which is 8. That means this block of addresses, it actually has 8 addresses. Okay, so I give you 8 addresses. So the second question I can ask you, what are the addresses of these 8 addresses? What are the addresses? Very simple. So actually, as I told you, this part is common. As you see here, this part is common in all of them. 29 here. So 29 bits are common. So all what you have to do, just change these 3 bits. So the address should be all, I change just the 3 bits. Okay. So all the addresses I have actually should be from 000 all the way until 111. So totally should have 8. Any questions? Any questions? Okay. The next example here, is an organization is granted the network address block. Again, this is a block. That means we have several addresses. Okay, this block is actually, as you see here, is actually this is the address I give to you. Okay, then here I'm telling you. So first of all, you should be, if I give you something like that, you can see here you have 26 bits in common. So here, if you have 32 bits. So out of the 32 bits, we have 26 in common, 26. So what is the remaining? We have 6 remaining, right? Six bits here. Okay, so because it's 6 bits, so how many addresses I give to you? If I give you this block, how many addresses? It's 2 to the power 6, 2 to the power 6. Okay, I think it's 64, something like that. Okay, it's because 2 to the power 6. Is that okay? But now I'm telling you, these addresses, I'm not going to use these addresses only for one subnet. No, I'm going to use it for four subnetworks, and that's what. So this is the second part of the question. In the second part of the question, I'm telling you, I want to create four networks. Okay, so what's going to happen here again? We are 26 bits. I shouldn't modify. Okay, so this 26 should be common in all addresses. Now we have 6 bits. 6 bits here. Okay, so out of the 6 bits, I want to create, I want to have 4 subnetworks. So how many bits I need for 4? I need 2 bits. So what's going to happen here? Out of the 6 bits, I'm gonna assign 2 bits for the subnetwork. Okay. So if I go back here, yeah. So here, one part of the network ID, this part in this example is actually 6 bits. So how many subnetwork I have? I need 4. That means this part has to be 2 bits. 2 bits, okay? And this part actually is going to be 4 bits. Is that okay? Because it is 2 bits, I can have 4 subnetwork, and because here we have 16 in every subnetwork, we can have 2 to the power of 4, which is 16 computers. Okay? And that's exactly what I did here. Yeah. So what I did here, as you see, this part is a complete byte. This part is a complete byte. This part is a complete byte, but this is not a complete byte. So here, this actually is 64, as you see here. Yeah. So here, this part is 64. So here, out of this one, as I told you, I can modify 6 bits. I can only modify 6 bits out of these 6 bits. So here, actually, I'm going to take 2 bytes for the subnetwork and 4 bytes for actually the host ID. So if you, for the first subnetwork, should have, because we have here 2 bits for every subnetwork. So in the first subnetwork, the 2 bits are 0, 0. In the second subnetwork, it is number 1, and then number 2, and then number 3. Only 2 bits. Okay. So for all addresses in this subnetwork, this part is common, 0, 0, and then we can change the host ID from 4 zeros to 4 ones. If you do that, you can get the range of addresses here. I'm going to start from 64 up to 79. Okay. Again, this part is common, but this part it's going to be from 64 until 79. If you look at the second subnetwork here, again, only, yeah, I'm going to give, this is the subnetwork ID, it's going to be number 1, and the host ID should be from 4 zeros until 4 bytes. If you do that, the range of addresses is going to be between 80 to 95. Again for 3 and 4. And this is actually how the network looks like. So here, this is the network ID for the whole site. Okay, as I told you before, everybody in the internet is going to see this site using this address, because this network address is common for the whole site. Internally, okay, as you see here, internally, we have here 4 subnetwork. We have a subnetwork with this subnetwork address. We have another subnetwork with this subnetwork address and subnetwork address. Again, I'm going to say it again. So outside world doesn't need to know the subnetwork addresses. This is something internally. Okay. So once the IP arrives to here, internally you can calculate the subnetwork address, and then you can decide should it go this way, to come to here or come to. Any questions? Okay, so last thing here I'm going to teach here is actually about why we have this hierarchy. What is the benefit of having this kind of hierarchy? Actually, I already mentioned all of them, but I'm going to go through them quickly. Number 1, the first benefit here. If you have, for example, if you have Is that a good idea? Why we make sub-network? Why we don't only make one network here in Qatar University, only one network? For sure, that's not a good idea. Smaller networks are easy to manage and troubleshoot. You got what I'm saying? So instead of creating a very large network, only one sub-network inside Qatar University here, it's better to create several smaller sub-networks because it's easier to manage and troubleshoot. Flexibility, very important, because every organization can decide its own sub-network, internal structure. It's up to you, okay? You can decide your structure of your network. You can also reduce the routing table interest because the outside world is gonna see you using only one network ID, the network address, okay? Aggregation. So here actually a complex collection of some sites. You have several sites who can actually aggregate the addresses, and I can forward packets to them using only aggregated addresses. Okay. Anyway, so are the benefits of all of them. The next one here. Again, as I told you, so now to finish this chapter, I'm going to teach two more topics. Number one, address assignment. How can you get an IP address? That's number one. Number two, routing. Routing is used to create routing tables. Okay. So let's start with the first one. Actually, here, how Qatar University is going to get a set of addresses first? Okay. Actually, what happens here, let's put the other way. I told you every country has a set of addresses. Okay, who's gonna give this block of address to these countries? There is an international company. This international company is called ICANN. Okay, ICANN. This actually is gonna manage the IP addresses. So, for example, this is gonna give some IP addresses to this country. Okay, and then this country is gonna give every organization a number of addresses. Okay. And then once you have a number of addresses, you are going to use so that's what you should understand. Qatar University has a number of addresses. Okay, it can use. Okay. What happens is that when a computer joins to the network, a computer has to ask for an IP address. Please give me an IP address. Using a protocol, this protocol is we call it Dynamic Host Configuration Protocol, or DHCP. It's actually a client and server program. So every time your computer, I have a very nice picture here. Every time your computer joins to Qatar University, your computer is going to connect to DHCP. This server is going to ask us, hello, server, please give me an IP address. The server is going to give you an IP address. And then once you leave the network, this IP address is going to be free. So it can be used, I can use it for someone else. You understand what I'm saying? So yes, so for example, you can use one IP address today, tomorrow someone else can get it, or even after you finish it, someone else is going to take it. Okay. So that's exactly what I'm saying here. You have an address. An address is assigned for a specific period of time in order to not waste IP addresses. Okay, so if after the period of time expires, the host address must return here. That means if you don't use, if I leave the network, so my IP is free, I can use it for someone else. You understand what I'm saying? So you should understand we have here what we call reuse of addresses, because every organization has a limited number of IP addresses. Okay, if you join, I'm going to give you an IP address. Once you are done, or once you leave the network, I can use this IP address and I can give it to someone else. Okay, I think that's enough. So starting from next time, I'm going to start teaching dynamic routing protocols. Okay?